So here's another one, and what I like about this one is that we could use the same problem but analyze it completely different. And I'll kind of explain it as we do it. So my toaster's broken. So here's my little toaster with its slots, and it shoots up a toast at 2 meters per second. So here's my toast, and it gets shot up at 2.0 meters per second positive. It's going up. And I know normally when you throw something up, it's going to go up and come back down and hit the ground. Here's my toast. Okay, so that's what I know. When something's in the air, almost always, A equals negative 9.8 meters per second. Okay, a couple other things that we know. This is called the max height. And this is when it stops moving. All right, so it says, what's the maximum height of the toast? So we want to know this one from here to here. Now, in reality, this is actually a pretty complicated problem because the toast in here gets accelerated first and then it lands below. But we're going to kind of fudge it a little. We're going to pretend it starts and ends in the same place. So instead of having the toast kind of end here, which will make life kind of hard, oops, did the wrong one. We're going to make the toast end here, which makes the life a little bit easier, and it will make more sense later. And I think I explain it right here, same height as toaster. But before we even get there, let's say from here to here, what is its max height? Well, we know max height ends here, so instead of having the problem go all the way back down here, for B, we're going to have the problem only go up. So here's my toast. I'm going to end the problem when it reaches max height. And the reason why I want to do that is because when I have my variables, VI, VF, A, T, D, we're looking for displacement. That's the max height. We know that the acceleration is negative 9.8 meters per second because whenever anything's in the air on Earth, we're going to say it's negative 9.8. 2.0 is the given. Now, we need one more variable in order to find D. If we set this as the end of the problem, then we know that the velocity right there is 0. If we make this the end of our problem, then we don't know the velocity there. Well, technically we do, but we don't know. So when this is the case, we're going to use the equation without D. So I believe it's this one, VF squared, VI squared, plus 2AD. We're going to solve for D. VF is 0. VI is 2 meters per second squared, plus 2 times negative 9.8 meters per second. And we're looking for D. So we get 4. I'm going to move it to the other side. So I'm going to do 2 steps at once. And you're left with, over here, negative 4.0 meters per second squared equals 19.6 meters per second squared times D. Move that over, so negative 4.0 meters per second squared on both of them, negative 19.6 meters per second squared equals D. The seconds cancel out. One of the meters cancel out, so you're left with the correct one. And my max height is just 4 divided by 19.6, which gives me 0.04. Sorry, 0.204. The negatives cancel out, so you're positive. Like I said before, if you did 0.20, that's fine. Either way, it's fine. I'm not a big deal about sig figs right now. On the next one, how long will the toast be in the air? So you have 2 choices to do here. We know, actually let's assume we don't know. We want to know when it comes back down. We're going to assume when it's right there. So if we go now, this problem, it's going to start here and end here. that means its displacement is 0. So now we have a different problem. Instead of going to here, now we're going all the way back down. VI, VF, A, T, D. A is always negative 9.8. We know VI is 2. We know, let's see, D is 0. So now we can figure out T. Or we can figure out VF. That's our next problem. So here we're going to use everything but VF. So I believe that equation is, let me try to think about it. Let me cheat a little. D equals VIT plus 1/2 AT squared. Plug in everything you know. Normally I hate this equation because you might get a polynomial, and I prefer not dealing with polynomials because it's just one extra step that I don't want to do with. And when we get to that point I'll show you, but sometimes it might be easier to find VF first. Alright, so let's just solve for this. You have, I'm going to move this over to over here. And get rid of one of the t's, and then you're left with negative 2.0 meters per second divided by negative 4.9 meters per second squared equals t. And oops, you could just do that. It becomes positive. The units is correct. 2 divided by 4.9 is 0.41 seconds. That's a t, sorry. You do the same thing, but this time we're going to solve for VF over here. Now we have everything. This is usually the easiest equation to use. I don't even have to use it. Actually, let's see. Let's use the one without t. So VF squared equals VI squared plus 2AD. And the reason why I want to do that, let me make sure, is because then I show you that you don't even need this answer to solve for this one. So VF squared is what we're looking for. VI is 2.0 meters per second squared plus 2 times negative 9.8, forgot the meters per second squared, times d, which is 0. So what's nice here is this becomes nothing. So you'll notice that VF squared equals VI squared. And then in this case is 2.0. So that's something that you eventually know. If it ends up at the same place, they're the same. But here's the big gimme. So VF, if you take the square root of both of these, is equal to plus or minus VI. It can't be the same as VI. So that's why VF in this case is equal to negative VI. Makes sense, right? Here is positive, here is negative. So by just doing this, you know that this is negative 2.0 meters per second. So that is something that you will now know. If we solve for time here, I want to show you another property, is that, let's see, the easiest one is this one, VF equals VI plus AT. Here VF is 0, 2.0 meters per second plus negative 9.8 meters per second squared t. Move the 2 over, negative 2.0 meters per second equals negative 9.8 meters per second squared t. Negative 2.0 divided by negative 9.8, and the units will be correct. It'll be the same one as this one. Equals 2 divided by 9.8, and it gives you 0.204. So it's almost the same as here. Now what you notice is this is exactly half. So the time it travels here is the same going down. So these problems, when we're not worrying about air resistance, the time going up is going to be the same time going down. The velocity right here is going to be the same velocity right there. So those are properties that you're going to memorize, and once it's in your head, you don't have to prove it to me. It's just givens. All right.